Hi, everybody. And this is the test number 4 review, part 3. And we're going to finish the last 5 problems for the test number 4 review. Hopefully, when the time you watch this video, you already watched the previous 2 here, right? Okay, so now let's take a look at the problem number 9 here. Number 9, we have 4 parts. So the first part is here. This is 2 to the negative 2 and 1/4. And the second part is here. This is 4/3 to the 1/64. And part C here is EX equal to Y. And the part D here is 10/3 equal to 1,000. So we want to rewrite this exponential form into a logarithm form here. So let's do a brief review. So basically, the formula we use, we said log B, right? Log B, x equal to the y. So this one's here is, you can say it's bx equal by, right? So by equal to the x. That's how do you flip back and forth between the log functions here. So now let's use this, and then we can start to see here. So for the first problems here, this is a 2 to the 1/4, right? So you just reference back to whatever you have. So in here you say, okay, so this is my b, and this is my y, and this is my x, right? So you will say, okay, so for this exponential, I can rewrite this. This is just log 2, and the 1/4 is equal to the negative 2. Okay, so it's pretty simple. So the next ones here is 4 to the 3rd, 1/64. So you do the same way. So you said, hey, this is my b's, right? So you just highlight. So this is my x, this is my y. So I have this relation, so I know the log. Okay, so the log b, so log b is 4. And x here, so it's 1/64 is equal to 3 here, right? Okay, so now the next one's here. So this is ex equal to y. So this one's here, this is your base, right? So this one's here, this is x, this is y. So now let's take a look, how do we rewrite it? We'll say it's log base, so it's e, and to the x here, so it's y. So this one's, I kind of get an x and y reversed, but that's okay. So this is log e y, and I know the log e is a very special function. So what is here is a natural log y equal to x is here, because we said we have 2 kinds of the log, right? The natural log and the common logs here. Okay, the last ones here, let's take a look at this ones here. So the same thing, you circle it. So this is my b, this is my x, this is my y here, right? Then you will say, okay, so this is a log b, so it's a log 10, and x is 1,000, y equal to 3. That's how you write it. Now we said the log 10 is a very special function. What is the log 10's function? Log 10, we just, typical, we don't write a base. We just write it this way. So it's a log, thousands. It's pretty straightforward, right? Okay, so now we use the same things. So let's do the problem number 10. We just go backward. We say, hey, if you give me a log, then how do I do, the exponentials here? So let's the part also have 4 parts here. So this is log, right? So this is a log 0.01 is equal to -2. Then here, this is log 216 is equal to 4. And this is C. This is natural log 1 equal to 0. And D is like a natural log E equal to 1. See here. So let's try to write the other way. So let's try to write to the exponentials here. So let's take a look at the first ones here. Okay, so the first one, so you just write it whatever you have. So these numbers here is my x. This number here is my y. Oh boy, I don't have here, I don't have the base. So remember, if a log without a base, so what is your base here will be? So base here is a what? So b is a what? B is a tens, right? So we said a base, if you have the common log, the base typical, we don't write it. Okay, so now, okay, I got everything here. Here just a little bit tricky, so the base is a tens here, you just don't write it. So then this will be the base, so it's 10 to the -2 is equal to the 0.01. That's how do we write it into the exponential. Okay, so let's try to do the number b's here. Excuse me. So this is the b, and then this is the relative positions x, this is y. Then you say, okay, so it's a by, so it's a 2 to the 4th is equal to what? Is equal to the 16. So it's pretty straightforward, just try to write it out. Okay, now like this, take a look at this one. Okay, this is natural log. Okay, so I use a different color. Okay, so this is a what? So this is the natural log 1. So this is my x, this is my y here, right? So we know the natural log ln has a very special base. So everybody still remember what is the base? Base equal to what? Base equal to e here, right? So now let's put it into the forms here. So it's by, so e to the 0 equal to 1, right? Okay, so the last ones here is the same way. So natural log e, so this is my x, this is my y. So the same thing for natural log is also, so what is the base? Base is e here. So that means e to the first power is equal to the e, right? That's what it's about. So this is a pretty, pretty straightforward. So basically we use the formula, how the log function and the exponential function, they kind of interchange here. Okay, so now let's take a look at number 11 here. Okay, so the number 11, they tell you you want to change that to the logarithm to write into the expressions, the sum, differences, or product, or so it will be the simplest of terms here. So let's take a look at this one. Okay, so this is a natural log 5 to the square root of the 7 and the 4 to the 3rd, and so this is a part A. Let's take a look at part B here. The part B is here, this is log 5 and 7y and the 5 square root of the y x squared, okay? So all these things here, let's do a brief review about our log functions here, right? So the log function tells us some key properties here. So here is if you have a base x plus base b, the y. So if you add to log, it will be log the base xy's, right? So the second property we say, if you have log b x minus another log, so what this one will be? This will be x over y's, right? Okay, so and then the next thing is here we say, how about okay, how about you have exponents here is r, right? So then we say, okay, the log function has a good property. You can take this r out and become multiplication to the base of the x's here. Okay, so now let's take a look how do we solve this one. Okay, so this one's here, this is natural log of 5 square roots of 7 divided by 4 cubed. So I know immediately divided by, I know it's a division, it's a minus, right? So this is a natural log of 5 square roots of 7 minus the natural log of 4 cubed, right? So from here to here, that's the property number 2. Right? You divide it is like you minus. Now in here you see, oh, this is a 5 and the square root of the 7. So the multiplication, I can change it to what? I can change it to, oh, I don't have a square root here, almost make a mistake. So I can change it to you add, right? So it's natural log of 4 cubed. Right, so this is used the property what? Property number 1 here, right? Now in here, let's take a look. This is the natural log of 5. So what is the square root of the 7? 7, square root of 7 is the exponents to the 1/2. Natural log of 4/3. And then now I can use the property number 3 to move all these exponents to the front here. So this will be the natural log of 5 plus 1/2 natural log of 7 minus 3 natural log of 4. Okay, that's it, right? Okay, so that's pretty straightforward, right? Okay, so let's take a look. The next one's here. Okay, so this one's here, the first thing you see, oh, log 5, 7y over, so I minus. So this is log of 5. So this is 7y minus, this is log of 5. This is 5 square root of the y x squared. Right, so I use the property number 2. And then now I can separate it. So inside the log of 5, 7y, because it's times, so I say log 5, 7 plus log 5 y here, right? Okay, now this one I can separate also, but be careful, you need to be careful. So this will be log 5 to the 5 plus log 5 to the square root of the y plus log 5, what? X squared, that's right? Okay, now continues here. Okay, so this is log 5 to the 7 plus log 5 to the y. So minus log 5 plus, we know okay, so this is log 5 square roots. So what is the square roots again? Haha, 1/2, right? Okay, so now this is log 5 x squared. Okay, now I see I have these exponents again. So I need to use the property, what? I need to use the property number 2. So here, I made a mistake here. So should be minus, right? Minus because negative carry over. Okay, so now the final answer will be log 5 to the 7 plus log 5 to the y. And we know there's a property also we says here, another property we list before. We say if this is a log b and b, if they are the same here, right? So we say if the base and the value are the same things, then become the 1 here, right? So let's write log 5 minus 1. Then this is the exponents. I can move the exponents to the out. So this is log 5 y. Then move this one out. It says move log 5 x. That's it. Right? So it's kind of like you just use the log properties. And then you try to do it. It's not bad, right? So it's pretty straightforward. Just need to remember. So you need to kind of put those property into a very handy place so you can review that. Okay, so now let's take a look at the problem number 12. I want to solve the equations here. Okay, so I have two problems here. A, this is log x 81 is equal to -4. Okay, so now the first step, we use the log function and the exponential exchange. So I know that x to the -4 is equal to 81. That's right. So like in the algebra, we know, if both sides, you have the same value, you can cancel that out. So now in order to solve x, I hope that, if they have the same exponents, then I can solve that, right? So I say 81. Okay, so 81, I say, oh, 81, that's good. 81 is 3 to the 4th power, right? So you say, okay, so this one here is pretty good. This is a 4. This is a 4. Oh, that's pretty good. And but for this side, I have a negative. I said if I do have a negative, then I will be able to solve it. Now you say, how do I change the negatives here? So you said, I hope that I have a negative here. But here's a positive. So I cannot just change it to negative. So I need to change a negative, add a -1 in here. So you see here, right? So that's the negative times negative will give you the +4. And now you say, okay, now in here, this function have -4, and this function have -4, right? On the exponents. Then you can cancel that out. Then that's what will give you, what is the x value? X is equal to 3 to the -1. So what is 3 to the -1? Is 1/3, right? Okay, now let's take a look at part B here. So here, this is the natural log x plus natural log x minus 3 is equal to natural log 4. So you say, oh, natural log plus natural log. Oh, yeah. A while ago, I know if natural log plus is multiplication. So I have natural log x times x minus 3 equal to natural log 4. Then you say, oh, okay, this side have natural log, this side have natural log. I can cancel that. So basically, then you will have x times x minus 3 equal to 4. So then let's FOIL it. So this is x squared minus 3x equal to 4. Then you -4, -4, both sides. Then you have x squared minus 3x minus 4 equal to 0. Then you factor here. Okay, so then you'll get x equal to 4 and x equal to -1. But I know the natural logs, right? Natural log cannot have the negative numbers, right? Because if you put a -1 here, get the negative number. So this cannot be the solution. So the only solution for here will be x equal to 4 here. Okay? All right. Last problems here. Let's take a look at last problems here. That's the number 13. Okay, so also we'll try to solve the equations here. Okay, part B, part A is here. This is a 4x minus 1 equal to 7x. Then you say, oh boy, the base is different, so I cannot cancel it. So what can I do? Well, one way we can do it, we can say we take log both sides, or you can take natural log both sides. Does not matter, right? They will get the same answer. So typical, we like to take the natural log. So I take the natural log of both sides. So I have a 4x minus 1 equal to natural log 7x. And then I'm using the log property. This is the exponent. So what I need to do? I move it to the front, right? So I say x minus 1 natural log 4 equal to the x natural log 7. And now I'm just using like the algebra part. I FOIL it, right? And then try to solve for x. So here, this will give you x, the natural log of 4, minus the natural log of 4 is equal to x natural log of 7. Okay, so I can just do like what we did before. So I minus x natural log of 7 on both sides. So this side will be x here, so it will be the natural log of 4 minus the natural log of 7 minus the natural log of 4 equal to 0, right? Then I can add the natural log of 4, add the natural log of 4 both sides. So the x equal to the natural log of 4 minus the natural log of 7 equal to the natural log of 4. Okay, let me move this one up here. So this is x to the natural log of 4 minus the natural log of 7 equal to the natural log of 4. If you want, you can combine a little bit. So this will be natural log of 4 divided by 7 equal to the natural log of 4. And in order to solve for x, you just do this, right? You divide it by the natural log of 4 over 7, both sides. See here, and here cancel. Then you will have the x is equal to what? Natural log of 4, natural log of 4 over 7. Right? So that's will be our answers here. Okay, so the part B here, right? So the part B is the same things here, similar things here. So like this is the 3x plus 1, 5x equal to 1. So I multiply the 5x both sides, right? So if you multiply the 5x, these two cancel. What do you have here? You have 3, the x plus 1 is equal to 1 times, so this is 5x, right? Okay, now it's back to the part A. Now I can take the log both sides. So you will have the natural log of 3x plus 1 is equal to natural log of 5x. And then the same way, you have exponents here, you have exponents here. So then you can move the exponents to the front. So this is x plus 1. The natural log of 3 is equal to x of the natural log of 5. Then what is the next things here? Distributed, right? Okay. So to distribute it, so I will have x, the natural log of 3, plus the natural log of 3 is equal to the x natural log of 5. Then solve for x. So I minus x natural log of 3, both sides. So on my left-hand side, this one cancel. So I will just have a natural log of 3 is equal to x natural log of 5 minus natural log of 3. If you like, you can simplify a little bit. Negative 5, natural log of 5 minus 3 is natural log of 5 over 3. Now you divide by natural log of 5 over 3, both sides. Then you finally, you can solve for the x, right? So then the x's here will just be the natural log of 3 and the natural log of 5 over 3. Okay, and that's it. That is all the problems we did for the exam number 4 review. Make sure you watch the video. After you finish watch the video, you need to cover up your problems and redo it without looking the notes to see if you will be able to reproduce the answer, right? If you just watch the video and do not practice, you might not be able to do very well in the exam number 4. So make sure, redo all the problems and to see you can match the answers or not. And that's it. And this is our last test, last midterm, and we have a final, all right? So good luck on your midterm number 4. After midterm number 4, we're just going to the review for our final exams here, all right? Okay, good luck and work hard, okay? Talk to you later.